Today we are going to be solving the valid parentheses problem in LeetCode. It's LeetCode number 20. So the problem here is given a string S containing just the characters open parentheses, open bracket, close bracket, and open square bracket and close square bracket, we're supposed to determine if the input string is valid. And an input string is valid if open brackets are closed by the same type of bracket and open brackets are closed in the correct order. So what does that mean? Some examples they give are for an open parentheses, it's closed by the same type of bracket, so that's true. In this example, all open brackets and parentheses are closed by the same type of bracket in order, so that's true. But then take a look at this one where we have an open parentheses and then a closed bracket, so these are a mismatch, so we return false. Another example where we have all the correct closing brackets, we have an open parentheses, a closed parentheses, an open bracket, and a closed bracket, but it's in the wrong order. We would need to close this parentheses before we open this bracket and close this bracket, something more like this. Here's another example where we have an open squiggly bracket and an open square bracket, and then a closed square bracket and a closed squiggly bracket. So this is still in order even though the square bracket opens and closes within this open and closed squiggly bracket. How would we go about solving this problem? Well, we need some way to keep track of which open brackets we've encountered and in what order, so that way when we encounter a closing bracket, we can check if it's the correct closing bracket, and if so, somehow mark that pair as complete so we can move on to finding a match for the next open bracket. There are a few different ways that this could be implemented, but the most efficient way is with a stack. With a stack, whenever we encounter an opening bracket, we can push the corresponding closing bracket into the stack because that's the match we're looking for. So this squiggly bracket would push this into the stack, and this square bracket would push in the corresponding square bracket into the stack. That way, when we encounter a closing bracket, we can check if it's what is on the top of the stack. And if so, that means it's a match, and we can pop that off of the stack and start looking for the next match. That way, if we encounter a closing bracket that is out of order, it won't match the top of the stack. What would this look like in code? So I have the solution coded up over here. The first step is just to create an empty stack. The next step is to take this string S they give and change it to a character array so we can loop through it one character at a time. So these lines deal with encountering an opening bracket, either an opening parentheses, opening squiggly bracket, or opening square bracket, and all we do is push in the corresponding closing bracket. So that way we have the match we're looking for sitting at the top of the stack. Now, this else statement deals with all the closing brackets. And so the first thing to check for is the stack empty? Because if the stack is empty, that means we have a closing bracket and nothing to match it to, so we would return false. The other case is we pop the top of the stack off and check if that matches the closing bracket we're looking for. If it doesn't, we return false. So after we loop through all these characters running this code, if we have an entry that is valid, we will have matched every opening bracket with a closing bracket and popped it off the stack. So ideally, the stack should be empty. If not, then we return false. Let's run through a couple examples to make this code a little more clear. So if we're taking a string S as a parameter, in the first example, S is going to be this valid string with this opening squiggly bracket, opening square bracket, and the corresponding closing brackets. So if we convert that to a character array, on the first run through, we're going to encounter this opening bracket, and so we add in the corresponding closing bracket. So now our stack looks like this. Next up, we encounter this opening bracket, so we add the corresponding closing bracket. So now our stack looks like this. Next up, we encounter the square closing bracket. And so this isn't an opening bracket, so we move towards this else statement. First we check, is the stack empty? No, it's not empty. And so then we pop the top entry off the stack, which is this square bracket here from the top. And then we check, is that equal to the character we're on? So is this square bracket equal to this square bracket? Yes. So we move on through the next iteration of the loop, where now we encounter the closing squiggly bracket. And so first we check, is the stack empty? No. And so we pop the top entry off the stack. So we remove this squiggly bracket from the top of the stack. And we check, is it equal to the character we're on? The squiggly bracket is equal to the squiggly bracket. And so we exit the for loop. We return, is the stack empty? And it is empty. So that would be true for this valid string. For the next example, we're going to be looking at an invalid string. So for this, when we encounter this opening bracket, we're going to add the corresponding closing bracket so the stack looks like this. But when we encounter this closing bracket, we'll check, is the stack empty? No. And so we'll pop the top entry off the stack, which is this parentheses, but that does not equal this closing square bracket. We have a mismatch, and so in that case, we will return false. Another example is if we just have this invalid string with one opening parentheses and no closing parentheses. When we encounter this opening parentheses, we'll add the corresponding closing parentheses, so the stack will look like this. But now we exit the for loop and we return, is the stack empty? No, the stack isn't empty, so that would return false. Another edge case example here is if we have a one character string that's just a closing parentheses. And so what that'll do is it'll immediately execute this else statement and ask, is the stack empty? And now in this case, since we haven't added anything to the stack yet, it will be empty and we will return false. So let's run this code and see what we get. As you can see, we get a very efficient solution.